So I wanted to address a few things based on some questions you guys have asked, specifically questions on, say, SiH4. And so we've got the Lewis structure here. All right, the total number of valence electrons, I'm going to skip over that for now, assuming that you are able to do that. So the number of bonding pairs, and again, I don't like the word pairs. I'd rather have domains here. And the same thing here, that should be domains. So the number of bonding pairs around the central atom is 4 and is 0. And we haven't filled in the hybridization column yet, and we haven't named the shape yet. We'll get there. But in doing the polar bonds, we want to know about the electronegativity difference. And I know in some books it says that if the electronegativity difference is greater than 0.4, then the bond is polar. And that's a decent cutoff. It's a little bit arbitrary. And so in SiH4, hydrogen is 2.1 and silicon is 1.8, so we get a 0.3 difference. Well, anytime there's an electronegativity difference, there's a little bit of polarity in the bond. There's a little bit of unequal sharing of electrons. And so if there's unequal sharing, I'm going to say that that's a polar bond. If we go strictly by the rules, and I'm looking through the book here now to see what this chemistry book says is the cutoff for a polar bond versus a non-polar bond. I don't think I see it in this book, and I'm pretty sure last year we probably, if we did this at all last year, I think we said the cutoff was 0.4, and I'm fine with that, 0.4, but realize that any difference in electronegativity is going to produce a bond that is polar. So I'm maybe instead just going to write in here, we'll go slightly polar. And then I think there was a similar question down here on PCl4 1+, so phosphorus to chlorine. I believe the structure was the same. We need to put in the lone pairs of electrons here on chlorine. And then we're going to put the brackets around it with the plus sign. All right, and again, we've got 4 bonding pairs, 4 bonding domains and 0 non-bonding domains. And so again, as we look at the electronegativity difference, chlorine has an electronegativity of 3.0, and phosphorus has an electronegativity of 2.1. So that's definitely a polar bond there at an electronegativity of 0.9, no matter what book you're looking at. That's definitely a polar bond. Now, the next step, and we'll do this in a future chapter, is the molecule polar. And that is a slightly different question. A molecule can be polar, the bonds can be polar, with the molecule itself being nonpolar. And in both of these cases, right, in the case of SiH4 and PCl4, in both cases there, the bonds are polar, but the molecule is not polar. But you don't have any way yet of figuring that out. You might have an intuition on that, but we haven't talked about that yet. So we will later. Hope this was helpful. Keep asking the questions.